project must be delivered on time, okay, should not spend more than what is allocated, and also need to meet quality requirements. Okay, so consequences of software with low quality. Okay, example what? The consequences of software with low quality. You read this small paragraph. Okay, so I assume you have finished reading this example. If not, you can come back here later. So this is another example. Okay, so why quality is important and what are the consequences of software with low quality. Can you read? Okay, so this is another examples. Okay, consequences. So these are bad consequences of because of low quality software. Okay, so this is example. Okay, so PayPal accidentally credit me with 92 quadrillion. Okay, so it's a big amount of money accidentally paying this amount of money to a person due to bugs due to bugs. So this is the amount of money, 92 quadrillion. Okay, so it's a very big sum of money. Okay, so software with low quality. Can you give one example? You have been using many software. I think some may be good, some are bad. Can you share with us? Can we share with everybody here an example of software of low quality and how it affects you? Anyone would like to speak? Okay, no one. Okay, example 4. Okay, so example 4, let me tell you this story. After the computerization of one particular process, okay, so the new system is not better than the previous manual system. So a computerized system, a process has been computerized, okay, to replace the manual system. Okay, however, the new computerized system is worse than the manual system. So the manual system is simple, straightforward, only need 5 to 10 minutes to fill up the expense reimbursement form. Okay, but the new computerized system, it took much longer to do the thing. Alright, expense reimbursement is an employee go to outstation to work. Okay, employee leave the office, okay, example, go to outstation to work, so the employee pay for his hotel bill, pay for his petrol, and pay for tolls and parking. Okay, so after finish the job, come back to office and claim for the money that he has spent from his pocket. So this is expense reimbursement. Okay. So using manual system is straightforward. Just fill the paper form and submit to supervisor for approval. Okay, but when this process is computerized, okay, so doing the same took much longer because the system is hard to use. It is confusing. Okay, so I would say that the system is completed on time. Okay, system is completed within budget. Okay, but the quality is low. That's the reason for this problem. Okay, so when you have a project, when you have to manage a project, you have to complete the project on time, meet budget requirement, and also must meet quality requirement as well. Okay, so it is not good enough to finish the project on time and within the allocated budget. Quality is also important. Okay, TOC means table of content. So the table of content for this chapter are quality concept and principal activities, quality planning, quality control, process and product quality relationship, and so on. There will be many, I will skip many slides in this chapter. Okay, so the importance of software quality. So why software quality is important is because organizations are relying more on computer system. Okay, so high quality software will increase productivity. Okay, high quality software will increase productivity. Okay, reduce stress. Okay, example. Okay, so on the other hand, low quality software will increase stress because it's hard to use, will increase your stress. Okay, it will not help you to do work in a faster way. Okay, so most safety critical systems have built-in software. So high quality software will ensure that system function as expected in all situations. Let me give you an example. What does it mean by all situations? Okay, so high quality software will ensure that, okay, this is an example, a car sensor will function as expected in all situations. Okay, example like function as expected during daytime, during nighttime, as well as during rainy time. So in all situations. Okay, so just for your understanding what it means by in all situations. Alright? Okay, software quality attributes. So quality simply means product meet its specification. So what's quality? So simple explanation is quality simply means a product meet its specification. As long as the product meet its specification, it is a quality product. Quality, so the term quality is subjective. Okay, quality is subjective. Something that's quality, to me, this is a product quality. This is a product. This is a quality product, but someone else may not think the same as what I thought. So you may think that what you have is quality. Okay, other people may think otherwise. So quality is subjective, but as long as quality meet its product specification, it is a quality product. Maybe is it a quality car? Maybe has its specification. Okay. Mercedes, is it a quality car? Mercedes has its own specification. Alright. As long as the product meets its specification, it is a quality product. When planning for quality, select the most important quality attributes for the software being developed. Alright. So there are many quality attributes here. So this is the quality attributes. So below the indented one are the sub-attributes. Okay. So functional suitability is a quality attribute. Functional completeness, completeness are the sub-attributes. The same for usability, this is a quality attribute, below are the sub-attributes. So when you are developing a system, can choose the attributes that are important for your system. Okay, so which quality attributes are important for an e-commerce website? Time behavior efficiency is important. Agree? Time behavior like page load time. Okay, so page load time should be fast. You should not take too long to move from one page to another page. Okay, learnability. Okay, so it is easy to learn how to use the system. Okay, for example, okay, using the system to buy a few items, check out and pay for it. Okay, should not be difficult. So these are two examples of quality attributes which are important for e-commerce website. So other can be user error protection. User error protection is important for e-commerce website, so the website should prevent user from making mistake. Okay, if there's no error protection, user will make mistake. Okay, so keep making mistake until the user will give up and will not come back to this e-commerce website. Okay, user interface aesthetic is important. The website should look good, not messy or ugly. Availability. Okay. Can you suggest one which you think is important for an e-commerce website? Any other one you think is important? User what? Tick already. Okay, any others want to tick? I think maybe there are a few more you can take. Okay. But when you are doing your assignment, you just take two only. Okay, you just do two. You specify two. Okay, so conflicting software quality attributes. Okay, so conflicting software quality attribute means you may want to increase security. Okay, you may want to increase security. When you want to increase security, you will not be able to increase performance efficiency at the same time. Okay, you cannot achieve this and this at the same time. If you want to achieve this, you will reduce performance efficiency. Okay, so increasing security may reduce performance. It may reduce user performance and may reduce system performance. So increasing security will reduce user performance because user need to perform a few more steps before he or she can enter into the system. Increasing security and also can reduce system performance. Okay, such as when you have an antivirus running in your computer, okay, it will slow down your computer. Okay, so customer quality requirements and developer quality requirements. So these quality attributes, most of them are for the customer. Okay, so most of them are for customers, and there's one that is for developer. The one that is important for the developer are this one, maintainability. This is important for the developer. Okay, so maintainability has nothing to do with the customer. It's not the concern of the customer. All right. So most of the quality attributes here, okay, they are for the customers. Okay, except this one. This is for the developer. Okay. So when planning for quality, select the most important quality attributes for the software being developed then develop a quality specification for the product. So to plan for quality, okay, you need to come up with a software quality specification. Your software quality specification should contain the name of the quality attribute, scale, test, okay, minimally acceptable or maximally acceptable. So your target range and what's the value now. Okay, so this is what a quality specification should contain. I would say this is a new version. After I finish, I'll put it in Google Classroom for you. Okay, so you can check out the updated content. Okay, so this is what a software quality specification should contain. The name of the quality attribute. Okay, so the unit of measurement for the quality attribute and so on. Okay, so quality attribute. So here, this is the name of the quality attribute, and here you define the quality attribute. So unit of measurement for the quality attribute. So what you will use to measure the quality attribute. So method or process used to measure the quality attribute. So for method or process, you may write down the steps. Okay, you use to take the measurement. Okay, so what's the minimum and maximum acceptable value? So target range is a desired range of value, okay, that you can accept. Okay, now is the current value. Okay, so let's look at this example. So modifiability is the desired quality attribute for a particular system. So definition of modifiability. Okay, so the definition is degree to which a system can be effectively and efficiently modified without introducing defects or degrading a system product quality. Alright, so here you state the desired quality attribute. Okay, write down the definition. Okay, so for scale, you specify the unit of measurement. For scale, you specify the unit of measurement for the quality attribute. Okay, so I use length of variable name, okay, to measure this quality attribute. Okay, so I use length of variable name to measure this quality attribute modifiability. Okay, so for test, you describe the method or process used to measure the quality attribute. So how I measure length of variable name? Okay, so how I measure length of variable name is I count the number of characters used in variable name in all programs. I check all programs. Okay, I check all programs. I count number of characters used in variable name, and then I calculate the average. Okay, so minimum acceptable. Minimum acceptable is specify the lowest acceptable value for the quality attribute. So value below this threshold means the product should be rejected. Okay, so after I count, I found out that average is 5 characters. For this one minimum, okay, so after counting, you may specify what is the minimum length that you can accept. Okay, minimum acceptable is the minimum length of variable name that you can accept. Okay, so you can specify what's your minimum length. Okay, so here this example is 5 characters. So below 5, okay, you cannot accept. So target range is the desired values for the quality attribute. Okay, so target range, what I can accept, what is good, what is considered good is 6 to 10 characters for variable name. Okay, so current value is 4 average. So the question is the desired quality attribute up to the desired level? So the desired level is 6 to 10. Okay, but you can still accept 5, but now it's 4. Okay. So is the desired quality attribute up to the desired level? Okay, answer is no. The desired level is 6 to 10. Okay, but you can accept. Okay, lowest is 5 that you can accept. But you prefer 6 to 10. Okay, now it's 4. Okay, it's not up to the desired level. Okay, so this is for modifiability. Okay, example 2. Okay, example 2. This is the desired quality attribute for a particular system, user error protection. User error protection is under usability. Yeah? So the definition of user error protection is degree to which a system protects user against making errors. Okay, so please don't talk so loud. Okay. So user error protection is a desired quality attribute. So this is a definition. Okay, so skills. So for scale, you mention the unit of measurement for the quality attribute. So how am I going to measure user error protection? I use percentage. Okay, so I use percentage. 0 indicate no error protection. Okay, 100 means a system has complete protection against user errors. So I use percentage to measure the amount of user error protection. So this is how I measure the percentage. Okay, this one. This is how I measure the percentage. Okay, so I examine all input screen. Okay, I examine all input screen. Count number of input fields with constraints. Okay, count number of input fields without constraint but with helpful labels or instructions, and number of input fields without constraints and without helpful labels or instructions. So this is step 1, step 2, and step 3. Okay. So minimum acceptable. Okay, so minimum acceptable is 80%. Okay, so 80% A plus B over A plus B plus C times 100. So the minimum that I can accept is 80% protection. I've written a note here, A plus B plus C is the total number of input fields in the system. So we look at all the input fields in the system. Okay, look at all the input fields in the system. Okay, so count number of input fields with constraints. Input fields input fields with constraints are sometimes radio button. Okay, gender where you select male, female. Okay, so this input field is input field with constraint because it has constraint because you cannot choose male or female. Okay, you cannot choose something else, or you can, and also you are not allowed to type anything into the gender field. This is the example of field with constraint. Drop-down list is also input field with constraint. You can only choose an option from the drop-down list. Okay, no other things that you can choose. Okay, so input fields. Okay, input fields without constraints but with helpful labels or instructions. This is also something that prevents user from making mistake. Example, handphone. Okay, for handphone, you may put a small note beside. Okay, example, the phone number that you want the user to enter. Okay, so there is input field without constraint but with helpful labels. This helpful label is to prevent user from making mistake. Okay, so A plus B, okay, so A plus B over total interviews, okay, so 80% is the minimum that you can accept. So below 80% you will reject, okay. Below 80% means there is not enough user error protection. So your target is 90 to 100%. Okay, the reason for this is to enhance user satisfaction. Okay, so now is 70%. So now is 70%, you can put an assumption. Okay, so you can put an assumption, okay, whether or not you have achieved the desired level of quality. Okay, so now is 70%, so is the desired quality attribute up to the desired level. So your target is 90 to 100. So the minimum that you can accept is 80. Okay, but now it's 30, so it's not up to the level of protection that you want to achieve. So what you need to do? So meaning you have to improve your screen design, okay, to increase the level of protection, okay, to prevent user from making mistakes. Okay, so this will increase the quality of your software. Okay, example 3. Okay, example 3, this is a quality attribute. This is a desired quality attribute, usability efficiency. Efficiency is how quickly a task can be completed. So I use time to measure efficiency, time in minutes to measure efficiency. So for you, you may choose a suitable measurement, whether it's hours, minutes, or second. It depends on your system. Okay. So I use time in minutes to measure efficiency. Okay. So describe the method or process used to measure the quality attribute. So I run usability tests with 10 drivers, record the time each driver took to pay for his or her street parking, and then calculate the average time for these 10 drivers. So maximum acceptable is average 6 minutes. Pay for street parking. The maximum time that I can accept is 6 minutes, more than 6 minutes. Okay, so this system should be rejected. Quality is not good enough. So target is 2 to 5 minutes to pay for street parking. Okay, so now is 3 minutes after 3 times of system redesign. Okay, so this is just an assumption. So it's the design quality attribute up to the design level. So the design now has achieved the desired level of quality. So now is 3 minutes. Your target is 2 to 5. Okay, it's within this range. So you have achieved the required quality. So when you describe the method or process, you use step. So write down the step, you measure the time. Okay. So software quality specification is to guide the development process to ensure the final products meet the desired quality standard. So this is to guide the development. Okay. So the reason for having this, or the reason for doing this, is to guide the development to achieve the required quality. Okay, so quality activities. Okay, so to achieve quality, what are the activities? So there are 3 main activities to achieve software quality. To achieve quality, so we have to carry out quality assurance. Quality assurance is to develop an organization framework Frameworks are procedure and standard that will lead to high quality software. Okay, and number 2 is quality planning. Quality planning is to select appropriate procedures and standards from the framework and adapt to specific software project. So quality control is to execute processes to ensure that software development follow the quality procedure and standard. So quality control are usually checking processes, checking activities. Okay, checking activities to ensure that you do what you say you will do. Oh, okay, I've forgotten 3 dots here. Okay, let me use FYP here to explain to you what's this QA, QP, and QC. Okay, so you can take a screenshot if you want, alright? If you don't take, also never mind. So just to use FIP to explain to you what is QA, QP, and QC. Okay, so QA is to develop an organizational framework. So framework are procedures and standards that will lead to high quality software. Okay, so over here we have this procedure for FIP. Over here we have this procedure for FIP. So you may start with submitting a proposal. Okay, so for FIP, you submit proposal to your supervisor. Okay, when you submit proposal, that means you are submitting Form 1, Form 2, and Form 3. After that, you write Chapter 1, write Chapter 2, 3, 4. So Chapter 4 is design. After that, you submit Portfolio 1. Portfolio 1, you combine the 4 chapters in one document and submit as Portfolio 1. After that, you proceed to write Chapter 5, 6, and 7. Okay, and then you submit final report. So this is the procedure for FIP. So start with submitting proposal and end with submitting your final report. This is the procedure. Okay. So standards. Okay, so there are standards that you need to follow. So when you submit proposal, you have to fill in Form 1, 2, and 3. Form 1, 2, and 3 are standard. Okay, so Form 1, Form 2, Form 3 are standard. So all students are to use Form 1, 2, and 3 when you are submitting your proposal. You don't create your own form. We have a standard form for you. These are standard form. Okay, you don't have to create your own Form 1 or you create a Form A, B, and C. You don't do that. That is not our standard. Our standard is Form 1, 2, 3 for proposal for all students. So it's consistent. Okay, so standard ensure consistency and quality. Okay, standard ensure consistency and quality. Quality in terms of we get all the information about you, or we will get all the requirement information from you. So for FIP, students need to follow this procedure. Okay, so these are the procedure to follow for FIP. Can you imagine we do have this procedure? Can you imagine we don't have this project? There are so many students and so many supervisors. So we will end up different quality of project because different students will do what the supervisor will ask you to do. There's no standard. No standard means no quality here. Okay, so the final report format given to you is also a standard, okay, to ensure quality. All the contents that you want to see are there. Okay, so these are the procedure. If an organization does not have a procedure, the organization need to create one. Okay, so we have this procedure. Okay, since we already have this procedure, we can still improve it from time to time. Okay, so if we are asked, okay, so if we are asked by student, okay, I want to do FYP, so what is it that I have to do to complete my FYP? So this is the procedure. Okay, and fill in the standard form. Okay, so this standard is to support the procedure. Okay, so these forms are standard to support the procedure. Okay, next. So next is quality planning. Quality planning, as mentioned in the PowerPoint slide, it says to select appropriate procedures and standards from the framework and adapt to specific software project. So here we have real-life project and non-real-life project. Okay, so what's the difference between real-life project and non-real-life project is, for non-real-life project, there's no need for you to write chapter 7. Okay, so real-life project, you have to submit 7 chapters, but non-real-life is 6 chapters. Example. Okay, so this is just an example. I'm not sure whether the committee have changed it or not. Okay, so for non-real life project, you do this. Real life project, you do this. So you choose the appropriate framework for different project. Okay, so that's quality planning. Okay, so quality control is to ensure that software development follow the quality procedure and standard. Okay, so QC is to do checking. So we ask students to submit form 1, 2, and 3. Okay, so we check. Okay, so QC to check whether or not you have submitted form 1, 2, and 3. Okay, and for portfolio 1, okay, we also check whether or not you have submitted portfolio 1. Okay, and also check whether in your portfolio 1 you have chapter 1, 2, 3, and 4. Okay, so make sure that all chapters are there. This is QC. QC is to do checking. Okay, and the same one for final report. Okay, so QC will do checking your final report to make sure that your final report have all the chapters. Okay, and follow the required documentation format. Okay, so QA, QP, QC are 3 main activities of software quality management. So to manage quality, we have to do QA, we have to do QP, we have to do QC. Okay. I hope you have some understanding. Okay. Okay, so let's look at the next part. So next part, techniques to enhance software quality. So how can we improve software quality? So there are 4 techniques here: inspection, green room software development, software quality, circle, lesson learned, report. Okay, so inspection is when a piece of work is completed, copies are distributed to co-workers who examine the work, noting defects or problems. So inspection is checking the output of work. Okay, so look at the output that a person has produced. Okay, check those output. Okay, so check the output. Okay, if there's any defects or problems. Okay, so for inspection, what you can check, example of work that you can check, okay, table design. So when you look at the table design, okay, you look at the number of fields in the table. So too little or too many? Is it too little field? Is there enough field in the table? Any field missing? Okay, when you use your eyes to look at it, okay, roughly we can know whether you have sufficient field or you do not have sufficient fields in the table, or there are too many fields in the table. Okay, sometimes for some system, in the table there are many fields. Okay, it can be up to 100 fields in one table. Is it good to have 100 fields in the table? It will slow down the system. Okay, it will slow down the system. It's not good unless it's unavoidable. Okay, so table with lots of fields will slow down the system. Okay, so you can check the table design, see number of fields, is it too many, too little, or any field is missing, or the field length is too long or too short. For FYP, for FYP, I usually notice field length is too long. Okay, field length is too long. Okay, if field length is too long, you are wasting storage space. Okay, so other things you can check is program codes. Okay, so program codes, you can look at the variable names. Okay, whether variable name is meaningful or not meaningful. So if too short, it is not meaningful. Okay, if it is 6 characters and above, okay, is acceptable and considered as meaningful. So program codes, for program codes, you can check the length of variable names. What else can you check? When you look at the program listing, you can look at the variable names. Okay, is it too short, too long, too short? You ask the author, okay, increase the length so that when someone else is modifying the program, it will be easier. So what else you can check from program listing? Christopher?
Yes, sir.
Fill in the blank. Give me one answer. Oh, body here, mind not here. Okay. Right? So program code, okay, you can look at the length of variable names. You can look at percentage of command lines. Okay, whether amount of command lines is too little. Okay, if there's no command lines at all, Do you have program without any command lines? All have. Okay, good. It's a good practice. Okay. So make sure that you have enough command lines in the program. Okay, especially when a particular module is doing calculation. Okay. So if there's no command lines, when someone else have to debug your program, it will be a nightmare to that person. So what else can you check? You can also check the UI, the screen design, okay, whether the terms you use is consistent or not consistent. Okay, font size, the font size in the UI, whether it's too small or too big or just nice. Alright, so these are some of the things that you can check with your eyes when you are doing inspection. Okay, so inspection is also known as FAGA method. So this method was pioneered by an IBM employee. You know this company called IBM? You know? IBM stands for? I don't know why I set alarm today at 2 p.m. Oh yeah, alarm 2 p.m. Don't know why. Forgotten already. Don't know why no notes. Okay, so that's inspection. So you check the outputs of work using your eyes, okay, and find if there's any problems. So these are the things that you can check. Okay, table design, program codes, okay, user UI, your UI design. So whatever documents produced, okay, from the project, you can check. Okay, so benefits of inspection. Very effective in removing superficial errors. Okay, so example like register, sign up for an account. So inspection can easily check superficial errors. Example like when in your screen design. So in your screen design, okay, so in the screen design, the landing page shows register. When you click register, the next page shows sign up. So you are not using consistent term. Okay, so this can be easily spotted, okay, when you are doing inspection in consistent terms. Okay, so inspection also can enhance team spirit. So we use inspection. Okay, we use inspection. You can use inspection by asking your peer to look at your work. Okay. You can use inspection by asking peer to look at your work, okay, and also you can help your peer to check the quality of his work, okay. So you help each other. Helping each other can enhance team spirit. Okay. So principles of FAGA method. So guideline. This is guideline for using FAGA method. So you can carry out on all major deliverables. Okay, output from system development. Okay, so can be carried out by colleagues at all levels except the very top. So you can ask your peer to help you to do the checking, okay, but not asking the CEO. Okay, so it's good to have a moderator. Okay, so when doing inspection, it's good to have a moderator. Moderator is a neutral person. Okay, moderator is a neutral person, so that when there's any argument, okay, so the moderator can calm down the situation. Okay, so will not lead to further conflict. Okay, so it's good to have a checklist. Okay, so have a checklist in fault finding process. When doing inspection, okay, it is good to have a checklist so that you do not miss out any important activity. Just like when you go to shopping, okay, when you go shopping, you should have a checklist. If you don't have a checklist, you go to shopping, when you reach home, this one forget to buy. Okay, so same thing for doing inspection, good to have a checklist so that you complete the inspection activity. Okay, so next is clean room software development. Okay, so for this we need 3 separate teams. Okay, next one, clean room software development. So this one needs 3 separate teams. So the first team is called the specification team. So this team obtains user requirements and a usage profile, estimating the volume of use for each features. Okay. So first team is called the specification team. So this team obtains user requirements, okay, and the usage profile, estimating the volume of use for each feature in the system. What is this volume of use? Okay, so this team gather user requirements and the usage profile, estimating the volume of use for each features. So a system has many features. Okay, so the system has many features. So this team also estimate the volume of use for each features. All right. For hotel management system, okay. So for hotel management system, check-in, check-out, volume of use is very high. This is performed on a daily basis. Alright, so printing monthly reports, okay, printing yearly sales report, the volume of use will be low. Okay, so printing monthly reports, printing monthly sales report, volume of use is low. Printing annual sales report, the volume of use is even lower. Okay, so printing monthly reports, printing monthly sales report, you may only do this once a month. So in 1 year, you only do it 12 times. So there is the volume of use for printing monthly reports. But check-in, check-out, okay, volume of use is very high. This is performed every day and many times in a day. Okay, so that's volume of use. Okay, so what does this tell you? What does volume of use tell you? So the volume of use can tell us, okay, how fast the bugs can be detected. Okay, how fast the bug can be detected. So check in, check out, if there's any bug, okay, you will know very fast because you are using it on a daily basis. So for printing monthly sales report. You may not able to take that is there any bugs, okay, 1 month later. Okay, and printing annual reports if there's any bugs in the programs is a year later. So this volume of use can help you to predict how soon you can find bugs in a particular program. Alright, so that's the first thing. First thing is obtain user requirement, okay, and estimate volume of use for each feature. So the development team deliver the code, okay. Development team deliver the code in increment, okay, but does not do testing on the program code produced. So the certification team will do the testing. Okay. So the development team deliver the code, certification team do the testing. So benefits of clean room, okay, lower number of errors, okay, lower number of errors because codes are developed by development team, but testing are carried by certification team. Okay, so this will result in lower number of errors. They are specialists in finding problems, finding errors in programs. So if development team develop the code and also doing the testing, most likely they will not be able to find as many problems or bugs as by the development team. I thought it turned out already. Okay. Okay. So second benefit is software of higher quality. Software is higher quality due to number of errors, lower number of errors. Okay, so lower number of errors means higher software quality there. Okay, so that's straightforward. It's a straightforward relationship. Okay, so lower cost. Okay, so lower cost, lower number of error means there will be less rework. So less rework is a cost saving. So project is on schedule due to less rework. Okay. So clean room development uses incremental development models. So project is broken down into several smaller tasks. Okay. So this allows project manager to produce better time estimate. So it is easier to come up with a better time estimate for smaller tasks. Okay. So coming up with a better estimate for big tasks, accurately estimating duration for a big task is not easy, okay, but estimating accurately the time required to complete a small task will be easier and more accurate. Okay, so weaknesses. So this technique works well with skilled and committed engineers only. So this approach is confined to a few technologically advanced organizations. So a big organization, a big IT organization can afford. Okay, so this kind of technique because it requires 3 teams. The first team is, what's the name of the first team? The first team is specification team. Okay, development team, certification team. Right. I would say big organization, big IT firms can afford these 3 teams. So small company I don't think they can afford these 3 teams. Okay, small companies, the software engineer will bow all these 3 tasks. Okay. So big organization they can afford this. So to have this team means to have this team To have this team means the organization need to set up a quality department. So need to establish a quality department. Let's take a 10 minutes break.
去朝鲜大陆，去朝鲜大陆，在骂人。
谁朝鲜大陆？
To do some work. Okay, so that means for about an hour a week to identify, analyze, and solve their work-related problems. Okay, so since there's a group, okay, so they since quality circle is a group, there should be a group leader. Okay, so can be one of the member can be an outsider. Okay, so in order to make quality circle work effectively, training needs to be given. Okay, so together the group select a pressing problem that affect their work, identify the cause of the problem, and decide on the course of action to remove the problems. Okay, so a faulty process will repeatedly produce faulty products. You agree? A faulty process will repeatedly produce faulty products. Okay, so quality circle is to fix the process. Okay, so that the same types of error will not occur again. So that's the purpose of quality circle. Okay, so it's like this. Okay, so we have input, process, output. Okay, can see, yeah? Okay, so input, process, output. So for software, what is the process? Analysis, design, code, test. This is the process. Okay, so what will be the output? The output is software and related documentation. Alright? Input are people. Okay, so input are people. So people follow this process to produce output. Output is the software or documentation. Okay. So if this process has problem, if the process here has problem, okay, output will have problem. If there's a problem in the process, there will be a problem in the output, in the software. If you don't fix this process will continue produce the same problem. Okay, so quality circle is to identify what are the problems in the process and remove the problem. Okay, so that when you remove the problem, okay, so then the software that you produce will become better. If you do not remove, if you do not identify what are the problems here, you will forever, your software will forever, okay, produce the same problem. The same problem will keep coming again and again. So quality circle is to look at the process, okay, find out where is the problem and remove it. Okay, so faulty process will produce faulty product. Okay, so if you do not find out what are the problem, you will forever produce faulty product. The product you produce will have the same problem. Okay, so quality circle is to gather, okay, find out what's the problem, remove the problem from the process, and the problem will not, the same problem will not come up again. Okay, so that's the purpose of quality circle. Okay, so the last one is lesson learned report. So lesson report is this lesson learned report is written by project manager. So lesson learned report is to reflect on performance of projects. So identify lesson to be applied to future projects. Okay, so after you have completed the project, okay, write down what you have learned after doing the project. Okay, what you are doing well and what you are not doing well. Okay, and how you can do it better next time. Okay, so there are 4 techniques to enhance or improve software quality: inspection, clean room software development, software quality circles, okay, lesson learned reports. Okay, so quality management and cost. Okay, so cost of quality. So what are the costs of quality? Okay, so cost of quality equal to cost of achieving quality and cost of low quality software. So this is the money you spend to achieve quality software, and this is the cost as a result of poor software quality. Okay, so this is the money you spend to achieve good quality software, and this is a cost as a result of poor software quality. Okay, so cost of quality can be divided into 3 categories: prevention cost, appraisal cost, and failure cost. So prevention costs are the costs to plan and coordinate all QA and QC activities. These are management activities. Okay, the cost to develop complete requirements and design models. Okay, so to develop complete requirements also involve costs. Okay, to conduct training associated with these activities. Okay, so prevention costs are costs to plan and coordinate QA, QC activities, to develop complete requirements and design models. So these are the costs incurred before development. Okay, so these are the costs incurred before development. Something that you have to do before development start. Okay, so the goal is to ensure that a project is error-free or within an acceptable range. So this is something that you can do before project start. Okay, so appraisal costs. So appraisal costs are costs of conducting technical reviews, cost of testing products, cost of collecting and reporting inspection. So these are the costs incurred when project development has started. So when project has started, there will be output. Okay, so when there are output, you can do technical review, you can test the product, and collect data and report inspection. These are costs because human effort and time are needed to do all this work. That's why it is a cost, because effort and time are needed. If you don't spend time and effort, okay, there will be problems here. The problem will move on to the next stage. Okay, so these are checking activities. These checking activities are cost because require human effort and time. Okay, so this is to ensure that project is error-free or within an acceptable range. Try to get rid of some problem when project is started. Okay, so the last one is failure cost. 2 failure costs: internal failure costs and external failure costs. So example of internal failure costs are costs to correct design errors, costs to correct program errors. So these are rework. Okay, so these are costs of rework. So cost incurred prior to product delivery. External failure costs. External failure costs are costs such as resolving customer complaint, handling product return and replacement, providing helpline support, managing poor reputation, and loss of business. So these are costs incurred after the product has been delivered to customer. Okay, that's the reason why this is internal failure cost, and this is called external failure cost. So which cost is most costly or expensive? C, failure cost is most expensive or costly to a software company. So you should do something before development start, also something after development has started. Before you deliver any bugs to the customer. So these are management activities. These are technical activities. So how to avoid failure costs? You do A and B. You do A and B. Do what has been mentioned in part A and part B. Okay, quality standard. So earlier I mentioned to you, quality assurance is to develop an organizational framework. Okay, so framework are procedure and standard that will lead to high quality software. So quality standards are set of guidelines, system, methods, requirements, and specifications followed by organization to ensure consistent process, product, and service quality. Okay, so this is just what I want to tell you about quality standard. Okay, quality standards are just set of guidelines, system, methods, requirements, and spec. So the importance of quality standard. Okay, so to ensure that product, processes, and services meet customer expectation and comply with regulatory requirements. Okay, so then next is process standard and product standard. I don't want to use this slide. I don't want to use this slide. Okay, so process standard. Analysis, design, code, test, implement is the process. Okay, so analysis, design, code, test, implement is the process. This is a process standard. That means every time you develop software, you will follow this step. So analysis will produce requirement spec, design will produce design spec, code will produce program listing, testing will produce test report. So these are product. Okay, so these are the product. This is a product from this process. This is a product from this process. Design is also a process. This whole thing is a process. This whole thing is a process. Each stage is also a process. This is the product. This product is the output from this process, this stage. Okay, design spec is the output from the design stage. Okay, so these are product. So product standard, for test report, the product standard is, there's a tester name. Okay, so tester name, date and time value of testing. So the test data used for in the test and the test result. These are standard. These are standard means every test report must contain all this information. If there's no standard, you have to set standard. Okay, for program listing, what are the standard that you want to set? For exam paper, we have standard. Question 1, 2, 3, 4. Below each question, you can see 25 marks. Write a line. All are write a line, correct? All are write a line. So for question paper, we have something like question 1. The standard, then A. A bracket is like this for all questions. It is not one paper A is like this, then another A is like this. Then 25 marks below. This is a standard in question paper. Okay, all questions must follow this standard. Font size is 11. This is for exam. Exam, what's the process? Okay, make announcement. Please check your pencil cases. You start writing now. You have 5 minutes. You have 15 minutes left. This is process. So what is a standard? Exam paper, there's a standard format. Attention slip, there's also a standard format. Okay. So when you develop software, okay, you need to do testing. So output from testing is a test report. Test report is a product. So in the test report, you may set standard like there must be a tester name, date, time when you are testing, test data, test result. So every test, for every test, you have to produce a test report. And every test report must have this information. This is a product. This is a standard. Standard means every test report will have this information. If you don't mention the standard, different report, different test report will look different. There's no consistency. No consistency means rojak. Question paper also become rojak. Quality. That's why a standard is set for question paper so they all will appear consistent. Same font size, same numbering. Okay, give me example, program listing. If you are to set standard, what standard you want to set? author name? Who wrote this program? Is it automatic? When you write code, is it automatic? When you create programs, is it automatic? Yes or no? No. You have to type in now. Type in using command. Okay. Author name. Is it good to have this at the top? Anything else to add? Give me one to add. Don't smile, tell me one, give me one. Your program has a name, correct? How you name your program? Simply Talo. No standard. No standard. That means no standard roadmap. But table name you have standard. Table name will start with T. No. Okay. So these are example of this product, the standard set for the product to ensure quality, to ensure consistency, to ensure quality. If this info is not there, what will happen? If you cannot find this info, okay, you can find the author name, but you cannot find they created, they updated. Let's say like you can't find these two pieces of info. Okay, you don't know how old is the program. Okay, you don't know how old is the program. Okay, at least this tell you how long this program has been in use, when it was last updated. created, they updated, what's the changes made. So every piece of program should have this info. This is standard. If you have a software company, you can set this standard, okay, and ask all your programmers to follow. Okay, can you understand now? Process standard. These are product. These are the standard set for the product. Okay, so I'll stop here today.